Hey there, how are you doing, guys? I was gonna come in at 9, but with the impending clouds, I figured it just might make better sense to come in now. The unfortunate issue is that we're probably gonna end up being clouded out. I hope not, but it's possible that we will. So I figured I'd come in. So hey, here we go. I wanted to say hello to you guys that are here. Thanks, man, for coming along. I saw Rock out there. Brian Bruce is with us. Tim F. Genghis is here. I saw Tim. I told you. I mentioned you, Tim, already. Thank you. Farva's here, and Farva's doing some nice things for us. Thanks, man. And so is Rock, guys. You rock. You both rock. And of course Tara. I saw Tara out here. Marianne was here for a while, and a few others, which I'll get to if weather permits. But I wanted to share with you a few things. I know that some of you asking some questions. The way to see the moon in an unprecedented way is to actually go out and check out the site for the Lunar Reconnaissance Orbiter. That's LRO, and you want to go check out the quick map, the LRO quick map, and that's really cool. Amanda, you say you can't hear well. Maybe you might want to turn up your sound at your end, because my volume's pretty high over here. I'm maxed out into the yellow, so I'm sending out good signal. Those of you might be able to help her with that. But thank you, Amanda. It's nice to see you come out. Thank you. And Twist Tim Hansel, how you doing? We have some clouds, and you can actually see, it's pretty cool looking to watch the clouds go across the moon like that, but they do get in the way, and we can actually just knock out everything and just look at the clouds and look at the moon like that. I got quite a bit of the little setups here to actually show what's going on and change the screen around a little bit. One other thing I want to show you guys while we're seeing all these clouds here. For those that just joined us, I'm going to show you what happens. Okay, this is the telescope control system up here. Let me actually get us to the typical place I'm at. This is where I'm usually at. Okay, this is telescope control up in the upper left. This controls the telescope. This controls the telescope computer, which I'll get to. This also is a filter wheel. And the filter wheel allows us to cycle through many different filters. Like this is a straight through. All right, this next one here, you'll see it rotate in. You can barely see the moon here. It's actually what's called a narrowband filter. It's for when we're looking at very, very interesting nebula. And then this one rotating in, this is another one that's a slightly wider narrowband filter. This next one is the spectroscopic filter. It allows us to see the lines in a star's atmosphere. It'll tell us what's in the atmosphere of the star. This is being replaced by our new system. We just got a spectrometer for the telescope. And then 4 is just a black image, so a black cover basically that allows us to do what are called dark frames. And then 5 is the straight through, the one that we've been using. All right. So we have a filter wheel which goes through these various different filters. Now, what we're going to do eventually is implement our spectroscope, and that spectroscope will provide views like this. What is this? Well, okay, these are the lines that you see in stars. You might see emission lines, and in nebulae, these are called emission lines. This is what the spectrum will look like to us, and then we capture it like this. Okay, this system I just got, it's actually attached to a piece of hardware which actually does the spectrum. And actually, this is a spectrum here. What you're seeing here, this is a real spectrum of none other than a fluorescent light. All right, and these are in nanometers, which is a billionth of a meter. So light wavelengths are small even when they're longer. So in the shorter wavelengths out here, this is in the blue. These lines out here are in what is called the ultraviolet, and the visual field starts where the red begins. Okay, so the visual spectrum is here to here basically, and we have lines from an from a fluorescent light that are beyond your vision, that they're higher energy, and that means they're ultraviolet, and that's why they're blue here at this end of the spectrum. Okay, and then at this end we have the infrared way out here. This can see infrared as well, way out here, almost to 800 nanometers out there. It'll show all that. So we have a healthy view of stellar light that'll be coming in, and I'm gonna be working on getting that hooked into the main telescope so we can see it just like rolling through the filter wheel. And we'll be able to actually capture and see the spectra of the stars in ways never before seen. And why would you just want to see lines like this? Because it's going to show you, I'll be able to show you how stars were built, basically, by looking at what they leave behind or what they are showing us right now while they're fusing hydrogen into helium or more. So it's really kind of cool. It's basically, when I got my astronomy degree, it basically gave us, it showed us a whole bunch of things. I mean, we learned about spectra before we actually learned about anything else. This is my world. There's the house, there's the observatory, and here's my world. Okay, I put together that photo to kind of just illustrate in a comical way how my world actually looks. All right, so this observatory is called the John Zach Memorial Observatory, named after my friend John Zach. That's the plaque right there, and he was a friend of mine who was doing this observatory with me, but then he passed away. So when he died, I waited. I literally put away the telescope for 10 years, and then finally realized he would probably want to see this project finished. So I made it a remote system so we can run it from inside. Now we're doing a second one, and we got to make another world out in Arizona, and that one is underway. And Marianne, who you'll see in the chat here sometimes, Marianne Robb, she's helping me with a lot of the arrangements out there. I really couldn't do it without her. She's been fantastic. And she is tireless in her efforts to help me get this observatory in place out there. So much so, I think I'm going to have to name it after her. She's helping so much. Anyway, so that's that. Let's go see what we got here. Hey, look, we got a moon. So I'm cautiously optimistic that we can stick around for a while with the moon. Oh, yeah, sure. Just as I say that. Make a liar out of me. Man, that's crazy. All right, so anyway, so you saw then what I showed you was this is the telescope control. This is the camera control over here, this camera cluster. This is the observatory view down here. You can actually, I can actually move the camera. It's a pan and tilt and zoom camera, so I can move it around. And when I actually do move it around, you can actually watch it change the view, and we can zoom and so forth. The other thing is we have a planetarium, an interactive planetarium that is tied in to this entire system, so we can actually see what the telescope is going to see and how it's going to see it. So I like to usually park that over here, and then what we do is we actually look at the objects in the sky and say, hey, this is what we're looking at. And we have the ground over here. We can show the constellations. We can show the mythology of the constellations. We can show individual objects like the moon. It's not quite dark enough for the moon to be out. This is a beautifully clear sky here. And what you're looking at here is the same thing, that photo of my world. And if you notice, the horizons here are just beautiful. We got plenty of space to view things. And the reason the observatory is where it is because if we were to put this observatory closer to the house or in the back of the house, then we would lose our eastern to central view over the south, and then our southwest from trees out in the back. This is the perfect place for the observatory, and I don't care if it is sort of a big, it looks like a big white minion on the front lawn, doesn't it? It's a minion, see? Banana, but hey, actually, believe it or not, I dressed this up as a minion for Halloween. It got a lot of attention. So this is a wonderful way to visualize the sky, and the telescope is controlled here. right? So when we are looking at the moon, you'll also notice something else. As we zoom in, you'll see the word scope. That's because the telescope is fixed on where the moon is. Yes, see, there's the moon. You can't see it because there's clouds, okay? But when and if it comes out, we'll see it. And so this scope icon will move around as we go to different places. And then this is our grid that I use right now. This is the constellation of Leo the Lion that I'm at. You see those lines? Okay, I'll move these lines out of the way so you can see it. This is Leo the Lion. How do I know? Because when we do this, we can say, there's Leo the Lion. Okay, and Leo the Lion has tremendous numbers of dark sky objects in it. Okay, now why am I zooming in so much? Well, because when it gets dark, instead of stars here, we're going to see, or instead of like an occasional star, we're going to see a lot more stars. And let me just get rid of this here to show you. Okay, and we'll also see little red ellipses, and these little red ellipses are galaxies. Leo has a massive amount of galaxies in it that are beautiful to look at. Unfortunately, we can't look at them when the moon's out because the moon is really hard to peek through, you know. And many of the galaxies you want to see, here's the moon, are right about here. Yeah, there's a few over on the right side, but in any case, then as we zoom out a little bit, when we pull out here, then we have other constellations like this one. This is Virgo, all right? And Virgo is full of many galaxies. In fact, it's where the supercluster of galaxies is located, and the great attractor, the thing we're all heading for, is located in Virgo. And we will, in fact, be spending time looking through Virgo when it's clear weather. Right now, well, you see. So, but bottom line is, I really just wanted to show you what was going on there. So that's our planetarium view. So we have that view, we have the camera view, okay, the camera control, we have the telescope control and that control, and last but not least, we have the operations view, which is right here. Hi. And this one floats around. So when we're looking at something in the sky, I'll come over here and I'll say, hey, look at this cool thing right here, and I'll talk about that thing. And I'll move over to it and we'll check it out. Then, of course, I'll go back and slink back into my corner. But the nice thing is this helps us, and I think helps you all visualize better what's going on when I can actually show you and point and touch and move around things. So that's kind of what I do. All right, so there's the full screen right here that you're looking at right here. This is the full SkyTour LiveStream experience right here. Not this one. The clouds are nearby. Yeah, grr, you know, I don't want clouds. But this is basically it. And in the center is all the live view. Now, the nice thing is we can get rid of all of it, okay? And you can see just the view. We don't have to have this other stuff polluting the view. But we like to have it up there sometimes when we're actually doing our moving and so forth. And last but not least, which I didn't have up, is this guy, which I showed you earlier. So there's the complete view right there. You know, there's the complete view. If only the moon would come back. You can see the telescope is pointing up, and you can see clouds down here. Okay, you look in there, you can see clouds overhead. Yeah, it's my floating head, Karen. Yeah, it's like, ooh. But you know, I think hopefully you can tell I have a good time with this. Because I think that it's really kind of important. You know, it's really important to do this, and I think to I guess make this something that's a wonder for everybody. You know, and one of the things that I think is that astronomy is for everybody. Okay. All right, astronomy is for everybody. And so you don't need a science education to do this. You just need someone who can talk to you in a way that will be able to explain what's going on. You know, and I'm going to stick it out until around 9 to see and wait and see what's going on. I will keep an eye on the sky. But I did want to come in and show you, you know, the stuff coming up, like, you know, this guy here, the spectrometer system. And then from there, once I implement that, I think things are going to be quite a bit more exciting. You know. Yes. Oh, yeah, Marianne. Of course you have a voice. Why wouldn't you have a voice? You know. Oh, by the way, just so you know, this little black box right here is the spectrometer. And what we do is we actually take a fiber optic cable, which is right here. All right. And we attach that to the end here. This is called an SMA connector. We connect that. This fiber optic, the other end of this, is going to go to a connector that's going to be on the filter wheel. And we're going to be able to capture what's coming through the filter wheel, but only for the straight through filter. Maybe not. Maybe it'll be for all filters. And that will allow us to see the spectra and figure all this stuff out, you know, and so I can teach you about spectroscopy and what you can see from it. I'll tell you, it's not a very exciting view, you know, and I'm not necessarily talking about this one, okay, but it's not a very exciting view in terms of the night sky, but I see clouds. Oh, what am I seeing? I think I see an edge. I don't know. I see some vignetting that could just be false. No, it's not. The moon is back. Let me bring our moon into the view a little better, shall I? We're going to go here and head eastward. Look at, there it is. It's a moon. Oh, and there it goes. So, what can I say? I'll keep an eye in the skies. I just wanted to come in for a few minutes and say hi to you guys, and to mention that I'm very grateful for all the people that love to come into SkyTour LiveStream. Marianne Robb is here, and she's in chat. If you have any questions about SkyTour LiveStream West, she or I can answer those questions, because she's helping to put this all together out there. She's basically the Arizona point of contact, actually, for SkyTour LiveStream, and she is utterly amazing, you know. And she's a cop. That's right, she's a cop, and she's probably one of the nicest people you'd ever get tased by. Am I right, Marianne? Yeah, look at that. You almost want to howl at them out, like, you know, hey, look at it, like a werewolf. So yeah, hey Ronald, don't you be laughing. You know, Marianne will tase you. Yeah. Yeah, Marianne hasn't had the privilege of meeting many of you guys out here. She's been here before, out in the East Coast, but she's never had the privilege of meeting a lot of you at all, actually. So if you're ever in the Phoenix area, I'm sure Marianne would just love to meet you, you know, because what can I say? You might meet her at an arrest stop. So it's actually, you know, she's heard all those jokes before, I think. It's kind of wonderful having someone out there. I mean, you have no idea how it has taken the pressure off me, because there's so much to do. And she's actually a good planner. So you can talk to her and say, hey, I need to do this. And she'll say, well, you do that, you do that, and you do that. Basically giving me orders about the observatory. And it's like, I'm okay with that, you know, because she's got her pulse on it, and it's really cool. And by the way, in the chat now, you have P&K Space Imaging. If you haven't subscribed to P&K Space Imaging, just cut the garbage and go do that. See the moon we're looking at here? They do it 100 times better. My telescope and our observatories, both of them, you know, the east and west sites, are going to be tuned for looking at deep sky objects. Okay? Their observatory is tuned for looking at the moon and the planets. And they do that in an unparalleled way. And that's P&K Space Imaging. Go subscribe now. Keith, if you're out there, just put the link in the chat for people, okay? Or if any of you know that link, put that out there for them. Because it really is a wonderful site. And I have to always pay homage. The fact that this is here, the fact that SkyTour LiveStream is here, is due to Keith, all right, and Bill Skywatcher, but because they both really pushed me to try streaming, and I really resisted it. I thought, nah, I don't know. I mean, who's gonna watch? Believe it or not, I said that. I didn't realize what a family is, a family of people there are out here, and I not only realize now, I try to make sure that I say hello to every single one of these people. Every one of you, when you come out here, you'll find a personalized greeting. Like I'll say hello to Live Arizona Skies. I didn't yet, but now I just did. Okay, and I'll say hi to everybody else as I already have. To those that are here. And I do that because it makes a lot of sense to do. Like Donald Kunzer's here. I didn't say hi to him. You know, um, and I think Amanda Shaw. I'm not sure if have you been here before, or Twist Tim Hansel. I don't know if you've been here before. And Brian Bruce, I don't remember seeing you before, but maybe Daryl or Amanda, the co-hosts here with me, maybe they know, because when I'm working in the telescope like I'm doing now, I'm doing like 5 things at once, and I don't get a chance to look at the chat all the time. But it's cloudy, so I get to do it and I can look at it. So I'm not sure, and if there's someone I missed, it's only because, like, I know Jenny Jones. There we go. I didn't say hi to Jenny. So I want to make sure that everybody gets that recognition. And Marco's here, yeah. And Daisy and Zoe, hey, yeah, Clouds, Daisy and Zoe, yes. I hope Lane is well tonight. Lane is one of their cousins. And she usually has a pajama party watching SkyTour LiveStream with Daisy and Zoe. It's really cool. So you get to know a lot of people out here, a lot of friends, and they're very, very cool. And we're just waiting to see if there's going to be a break in the clouds. I looked at the weather, and the weather always looks more promising than it really is. But I know that it's actually going to clear up. It's going to gradually get clearer. That's what it says. And Marco, hey now. Yes, I've watched Howard Stern. So we'll see. I know that I will try to look right now. So I'll check out the weather, and I will be back in a little bit. If you got any questions, queue them up, because I'll come back and I'll check them out. Right? So I shall be back in just a few minutes. you know, never let it be said that you know, if you come here to SkyTour LiveStream that you're gonna go away without seeing something. I mentioned earlier to those watching that the LRO Quick Map is a way to see things on the moon in an unprecedented manner. So you know what? I'm gonna show it to you. To find it, find this site, all you have to do is look up LRO Quick Map. So LRO Quick Map, all one word, QUICK-MAP, Quick Map, and then browser. So you say LRO Quick Map browser, and you get to see the moon. All right, and here's the moon, and you actually get to zoom in. Now this is Copernicus crater right here. Okay. Now, down here at the bottom, it tells you what the latitude and longitude on the moon is and how many meters per pixel you can see. So right now, it's 463 meters to one tiny picture element if you zoom in, all right? And if you zoom in more, you'll notice that changes. Now we're at 152 meters per pixel, almost 153. But let's suppose you want to zoom into this little crater. How far can we go? We can go in, and now we're at 6.54 meters per pixel. And what happens is, as you get closer, you'll see the data change, because now you're getting other passes from the Lunar Reconnaissance Orbiter that actually did refined and higher resolution data. Almost looks like a footprint, doesn't it? But look at this. We can go in and in and in into this little crater so far, in fact, that you can see tiny little craters in the wall. This area here is an area of lesser data, but from out here it looks pretty darn good, but it wasn't the pass that has been filled in yet with the high-res data. It doesn't mean NASA's hiding anything, because they're certainly not. It means that the data has not come in, and so we can go even closer. This is 3 meters per pixel, and we can go even closer. All right, and we get down, you'll see the data now sharpens up even more as you scroll in. All right, and we're going to focus on this little crater right here. And now we're at 1.37 meters per pixel and 1 meter. And now we're at 0.79 meters per pixel, 0.6. And then finally the highest res here, 0.5 meters per pixel. All right, now that means we can see something on the moon that's just about 30 feet across to, well, 15 to 30 feet across. And then there's other things you can do. On the left side, you see these menus here, all right? And, okay, this says toggle full screen. This is settings. And this is the draw and search tool. What is that? And don't worry, I'll come to these in a minute. Well, if you click on that, you get this up. And now we draw a line, okay? And let's draw a line from here to here, okay? Now, what is that? It's showing us the slope, and you can see how it changes on the moon from the left side all the way down, and wherever we go, there's the deepest part of that crater. It's right there, right? And it's an uphill crater, if you notice. It's actually going uphill, all right? And it gives you a value down here, okay? If you look at, there's a value that's shown in the numbers just below the cursor now, the orange bar on the left, and it shows you the altitude. All right, and it's showing us the altitude based on the mean radius of the moon. So it can be a plus number or a minus number. Okay, and there's more data you can get from this. All right, but the most important thing that you can get away is you can see the distance. It tells you that that crater is 0.042 kilometers across. All right, and now if you want to know what 0.042 kilometers is, you can go into Google and say 0.042 km in mi, or any unit, and you'll get a response that is not what I thought. Okay, I must have typed something wrong. Hold on. Maybe I have to be more specific. I just did this, and so it's giving me different results. There we are. Okay. All right, that's basically 0.026 miles. Okay, so it's not even quite a tenth of a mile. Okay, so that's pretty cool. All right, so if you want to do it in miles, well, you can figure it out, you know. So this is neat. This is a great way to look at the moon and see things. And if you want to just throw that away, you can just get rid of that measurement, and now you're back. This list here, this is really interesting because you can see all the many different missions to the moon and what they're showing you. All right, and you can pick any of them. Like, for instance, you can say, for instance, if you come down here, you can look for, I look at overlays, and for the overlays, the one thing that's very important is you get nomenclature. Like, what's the name of that crater? Okay, so when we back out of this here, all right, we're going to start to see names. Okay, and now we see this is Thoth. Okay, this little crater that we're looking at here is Thoth. All right, and I think that as we back out, you'll see many, many more. Okay, and now there's Copernicus. All right, now we can zoom in on that. Oh man, you zoom in on Copernicus, you watch the data change. All right, let's go to the rim right here. Check this out. Okay, there's an area of lesser data that is yet to come in. That is to say, the Lunar Reconnaissance Orbiter hasn't brought it in yet. But look what happens when we zoom in. Let's go right here, in fact. This is, now we're down to 0.66 meters per pixel. And there it is. That's the maximum resolution. And you can see a line of boulders and so forth on the lunar surface. Okay, some of these boulders are the size of a house. Okay, but you can see them. And it is an amazing view. And like, here is a crater right here. You can actually see the debris in the crater. It basically hit there and blasted out. It wasn't enough to make a very deep crater, but it did that. Isn't that cool? Just very cool. You know? And if you think you're stuck on the near side of the moon, let's turn off nomenclature for now. You're not, because you can actually pick what you want to see, all right? And that comes from this switch projection tab up here. There's a little tiny button up there. We can look at the near side. We can look at it as equidistant cylindrical model, okay? We can look at it from the South Pole, look at the South Pole of the moon, in which case you can see the permanently shadowed craters, all right? In fact, when we, let's turn on nomenclature. Can I do nomenclature now? I think I can. Hold on. Because I want to show you Cabeus crater. This here is this crater right here, Cabeus. Cabeus is a crater that was used by the L-Cross experiment. They crashed a satellite purposely into this crater, and they looked at the splash to see if they could see water, and they did. So that's not, doesn't mean that the moon has water in there. It's not water. It was ice, of course. So that they were looking for ice in the permanently shadowed craters to see if it would make sense, say, to put a moon base here on the South Pole of the moon. And it does. It makes sense to put it there. But as it later turned out, the lunar soil has trapped a lot of H2O in it as well and bound up with the hydrogen and oxygen of water. So we can actually extract water from many places on the moon, and it doesn't have to be from within a crater anymore. That is the coolest part. So now we can actually put a moon base inside Clavius and recreate 2001: A Space Odyssey, which I think is neat. All right, so that's another projection there. You can look at that orthographic South Pole. We can look at the North Pole. All right, this is the North Pole. Again, same type of situation. The South Pole has highlands, so we actually, can see more permanently shadowed craters down there than at the North Pole. All right, so that's pretty interesting. But then this is the one that's, I think, most people's favorite. This is the lunar globe. The lunar globe, and no, it's not new moon. I'm just waiting for it to come in. In fact, I'm surprised it's not here already. The lunar 3D globe. Okay, I see why nomenclature was on. I'm going to turn that off so we can see it without that. Okay. All right. So now this is the lunar globe. Now what does that do for you? Well, that does this. Now you can spin the moon around any way you want. Okay. Oh, and yes, don't worry. You can zoom in to your heart's. Oh, an error. Oh, look at this. I must have gone too fast and overwhelmed it. Just what we need, right? So let's do it again. I've never seen that error before in my entire life, just so you know. Yeah. Oh, look at that. Wow. I've never seen that. Of course, it only happens when I've got people watching, you know. It's all right. Let me just see if I can grab the near side again and go back to the far side. The far side. Yeah, that's great. I see it trying to come in. There we go. Now let's see if we can get the lunar globe to come in again. All right. So again, in the same way, we can move around and go through, but there's something else you can do with this, which is really cool. You can come down like this, okay? And then you can do something really neat like this. This is a middle mouse button routine right here. You just hold down your middle mouse and now you can do this. And this, okay, up here, this is Plato. Now, where does Plato show up normally? Well, we look at the moon in general, right? This is kind of how we see the moon. Plato is sort of up here. This is Merimbrium. Okay, this is Copernicus. This is Aristarchus over here. And so this is Merimbrium. It's very prominent. And we can actually zoom in on the 3D version here. And by pressing down the middle mouse button, we can now deproject it to our heart's content. It is so cool. Now, we can do something else. See this button up here? No, you can't. Not really yet. Let me help you see that button. Now, there's a button in the upper right that you need to see. I was a little bit off in getting this. Let me do this for you here. I'll bring it down. Okay. Okay, so now you see this button up here. It's that little circle right there. Click that once, and now you click anywhere on the screen that you want to go orbit around. Let's pick this crater. We click it, and now we're orbiting this crater. You'll notice that it's moving slowly. I'm not doing that. It's causing this orbit. We can zoom in. Okay, and the image will get clear as better data is brought in. You can change the altitude and zoom around like this. All right, isn't that cool? And when you get close, now you see some really good data. It really is beautiful. That's just a beautiful function that's within this LRO Quick Map browser. All right, and you know when we do things like that, we can pick a different place to circle around if we want to. This is Plato, the one I told you about. It's 60 miles across, but you don't have to take my word for it. You can go to the search thing here, the search bar, and draw a line. Right, and I don't know if I can do that in here, but looks like I probably doesn't want me to because it's not letting me do that. Let me get out of the 3D globe and go back to the orthographic near side, the way we see it, in other words. Okay, now if we come down here and we draw a line across the center of Plato, and I'll do it by let's do this. Okay, let's move in here. We have to I messed up there. Okay, so we'll do this. And you can do as many as you want. So for instance, from the plains out here to there, to the other side of Plato, you can see it's really low out here in Merimbrium. And then it goes right up for the wall of the crater. As you can see, there's a little cursor on the main view with it's yellow crosshair with a circle in it. That shows you where you are as we're moving across the cross section here. And then Plato it's pretty shallow right about there. All right. So now if we want to actually do this again, we just say, well, let's do it again. And you grab it again. All right. And we already have one path on here all the way. Anyway, so that's what that is there. Now we can just click here again and go all the way across, and then double click when we want to stop. And the cross section gets drawn over there, and you can see that we are starting from this area here, and we come across, and the relative size of this wall on this far side of Plato is much bigger than the relative size of the wall on this side. So it's pretty clear, you know, that's the way it is. And you can hit the garbage can to get rid of these measurements. Okay, there's one here we can get rid of too. So that's a little cool thing. This is the Lunar Quick Map browser. Now, if you don't want a Lunar Reconnaissance Orbiter quick map. If you don't want to play with this, well, no one says you have to. You know, you can have some fun just zipping around the moon. And for those of you thinking, hey, what about the Apollo landers? You can find those too. You can find all those things. And for instance, if we look at some of the sites here, let me just turn this on here. If we look at some of these sites, we can actually see that many of these features are places where we have actually landed on the moon. I'm trying to see here. Okay, like as you zoom in, you'll actually see the spots, like this one. Okay, this is an anthropogenic feature, a feature due to human involvement. Okay, this is the Apollo 14 landing site. All right, and as we zoom in, we should be able to see all the experiments on the surface and the descent module of the lunar module, descent module them. And what are these? Why, those are the tracks, okay, that the astronauts walked in. This is the descent module right here. We can actually change the opacity of this label so you can actually see a little better. Okay, so now you can see this is the extent to which they went. They landed, they went out here. This is what they call the ALSEP experiment right here. You can see by that bright thing. And then they walked back here, and this is where the lunar module is. There's the shadow of the descent stage. Okay, now this is cool stuff. You just don't get this, you know, and it's made publicly available, you know. And you say, well, why can't we see this stuff with a telescope on the moon? And there's another track right here. See it? So they went out pretty far, okay, all the way out to there, all the way out to here, right? You know, they went quite a ways, all right? So, but you say, well, why can't we see these from the Earth or from a telescope? Well, look at how small it is, okay? Right now, we're basically at the altitude that the Lunar Reconnaissance Orbiter went over the moon with. Okay, and now this is how the moon looks from the Earth. Okay, when we come back, right, and it's way smaller, so it's going to be like smaller than this. So you can see how you couldn't, with no matter what you have for a telescope on our planet, you can't possibly see where they landed on the moon, and neither can the Hubble Space Telescope. The Hubble simply cannot see with that kind of resolution, believe it or not. It can see gigantic galaxies, it can see gigantic nebulas, it can see all those things beautifully, but it can't see these tiny features in the moon. These are actually small features compared to you know, what normally is seen on the moon. I'm sorry, in space. These are really tiny. Okay, now if we were to come up here now, all right, and go over here, then let's see, right in here, I'm trying to find, there's a landing site up here. Did I check it off, or is it, oh sorry, I got the opacity turned down. Let me turn it back on, and I'll bring them all back. I was wondering why I didn't see anything. Okay, so am I in the wrong spot or what? I don't think so. That's Surveyor. This is Surveyor, was another soft lander. Now here's what's interesting. When the Apollos landed, before they landed, they actually the command module turned around and pulled the lunar module out of another stage. It was called the Saturn 4B stage. Then they jettisoned it, and guess what they did? It crashed and made a crater on the moon. So here is that crater for this particular, for Apollo 15. There's the crash, there's the debris you can actually see, and you can see that it scattered debris this way and that way. So it means it came from this direction, hit, and then went poosh, like that. And because of the contours here, most likely there was a ridge here that stopped the material from splashing this way, and it only kept it going that way. The topography of the land is what determines which way the rays go. All right, so this is really interesting. And of course, the direction the thing's moving when it hits. Okay, so that's another example of a human-made feature, actually a human-made crater. All right, so now as we back out, we can go and look at a number of different locations. Now Apollo 17 had the same thing. Okay, Apollo 17, when it landed, they pulled the lunar module out of the third stage, that fourth stage, I mean, and it crashed on the moon as well when they were done with it. And there's its crash site. Now you don't see rays coming off. You see a few this way, okay, a little bit that way. So this landed probably more directly, and there's a few scattered stuff this way, a little bit that way. So it landed more or less directly. But man, wouldn't it be great to just go see this debris right now? Oh man, I'd love to just go visiting all these debris craters and check it out. You know, can you imagine how much we'd get selling that stuff on eBay? We would never have to work again, guys. Let's figure it out. Let's figure it out. Let's do it. So there it is. That's the quick map. That's not by far. That's not all the places on the moon that we've been. There's actually a lot more, and the Apollo 11 is here, and we have I think one of these is Apollo 11. That's Ranger 8. Okay, and what's this one? Is this another Ranger? Yeah, Ranger 6. And I think, oh, sorry, I think this was down here was Apollo. What are the Apollos? Surveyor 5. Apollo 11. There's Apollo 11 site. The first landing on the moon occurred right here. Now, what's interesting about this location? Oddly, when you come down here, you can barely see evidence that we were there. And you know why? Because at that point, when we came here, we didn't know where to go. Oh, there it is. We didn't have an idea of where or how far away from the lunar module we could go. So if we kind of make this here, you can actually see the descent stage of the lunar module right there. And you don't see a whole lot of tracks, do you? They didn't really go that far. They went a little bit out to here, a little bit over to this crater, and they didn't go very far. First time on the moon at all, you know? But that's what they did. So isn't that neat? There's us on the moon. You know, human beings reach the moon. So, you know, and I know some of the Apollo astronauts said, oh, you know, we're not alone. You know, unfortunately, some of that stuff was misconstrued. I've met some of the Apollo astronauts. I actually had dinner with Alan Bean, and, you know, Captain Bean and I sat, and in fact, he was speaking at a location where I actually worked at one point, and we started talking, and when the director of the Science Center said that they were going to take Captain Bean out to dinner, Alan Bean turned to the director and said, "Can Mark come too?" I'm a peon at that point in that place. And the director of the place didn't know what to say, and he said, "Oh, yeah, sure. Mark, come along, join us." Well, Alan Bean sat with me at the dinner and talked to me for the next 2 hours. And the director was sort of sitting there pretending he was interested, but he felt kind of bad that Alan Bean was not paying attention to him, I think. But you know what? We had a lot to talk about. He was an artist. I was an artist. We were doing artwork of space together. And we just kind of hit it off. He was a great guy. One of the nicest men you'd ever meet, too, actually. You know, very, very, very gentle man. So a very, really nice person. So, you know, so we have, you know, there's a lot going on here, you know. Now, if you remember Apollo 17, look how good we got. By the time we landed Apollo 17, we landed in between mountains and these little tiny areas. Apollo 11 shot for a plane, a flat plane, because, you know, they had to be careful. They didn't know how well the lunar module was going to steer. And then comes Apollo 17, and we're landing near craters. We're landing in these areas. Literally, the technology jumped so much in that intervening time, you know. But you can see the tracks here. Let me just get rid of the stuff so you can see it. There's the lunar module, the descent stage. You can see they went out. They had a rover. They actually went quite far. You really can't see it, but they actually went all the way down here and spent a lot of time rummaging around on the lunar surface. And by the way, in some of these, you can actually see the shadow of the flag on the ground. Not in this one. But man, you could see it. And I was like, wow. So, you know, when people say, oh, we never went to the moon, you know, it's like, you know, don't embarrass yourself. You know, don't embarrass yourself. We did. I lived through it, actually. I watched Apollo 11. I watched the astronauts walk on the moon, you know, and it was lousy TV coverage. It was grainy and had bands in it, but it was amazing. I was glued to the TV, you know, and it was actually just a cool thing. So we have been to our nearest satellite, and I think we'll have the same controversy after we land on Mars. We didn't really go to Mars. It was a fake landing, you know, that kind of thing. So let's see what we got for a remote view right now. Do we have any moon? Now see. Let me see what we've got. Yeah. Okay, it's 8:55. The 9 o'clock official start of the stream would begin now. Man. Oh, Carol, it was a wonderful dinner. I don't even remember what I ate. I was just too intrigued listening to Captain Bean. You know, and I ended up buying one of his paintings, believe it or not, later, which he signed for me and everything. It's just beautiful. It's here. It's actually in a closet. I haven't even put it up. It's all framed and everything, and it's one that he painted, so it's just beautiful. The man was a tremendous artist. Anyway, I am thinking as I come back here to my remote view, as you can see down here, right here. These are clouds. You can see them moving. Kind of looks like storm clouds, doesn't it? But it's actually not. It doesn't have any precipitation in it. That was big drops, you know. Okay, well, you know, we gave it our best shot. I really wanted to, you know, hang out here with you and see what we could do. I told you we're going to do the spectrograph. The spectrometer is going to be attached to the telescope. We're going to be able to check the spectra of the stars before long. I have to just figure out how to integrate all that, and then we'll be able to do it. And then get it down here. So we'll actually be able to see these views live. Okay, and we'll be able to, you know, see all this stuff live. And that's kind of key. And actually, to show you what that looks like, I'm actually going to turn on a light here that I'm going to use. And we'll see what we can do here. Let me just turn on the lights. All right, and I'm going to turn the spectrometer toward the light. And go to the light. And connect it and acquire in continuous mode. Yeah, okay. I might have to just start it all over again. I may have to. That's okay. All right, there we go. All right, so now you'll actually see the spectrometer go here in a second. You'll see the lines begin to acquire. Okay, and you'll see them momentarily. Just a sec. Oh, wait a minute. Little things. This is software that I'm using. It's from France, so I am doing my best to learn how to use it. Okay, here we go. Okay, and now let me get set up right. I'm trying to get the light in here. Acquire. Okay, so now I'm going to acquire the spectrum of the fluorescent light. So this is the live spectrum that we're getting right now. This is as literally coming in as the spectrometer is reading it. Okay, so we're seeing it again, moment to moment, live from the light. Now imagine this being a star. We're going to see all these dips. You'll notice they're moving. We got values here. The wavelength is in nanometers. We see a representation of the spectrum. Then the stuff in the red, this is the visible spectrum. This is what your eyes see. Out here, you can't see this. This is ultraviolet. Out there, you can't see this. This is infrared. The spectrometer that we have can see the infrared and the ultraviolet. So that's going to be really cool to explore that. And we're going to do that. We're actually going to see how that all works. So there's a lot of things here. We can actually add more labels to some of these peaks if we want to. And over time, because I calibrated this spectrometer, this frequency right here of 529, that's right about the maximum green frequency that you get from a fluorescent light. And the fluorescent lights, if you notice, if you ever remember, you take a photo with fluorescent light, and what color does the image look? It has a greenish cast, doesn't it? Well, no surprise, because look, it has a green line right there. This is an emission line. It means that there is a hotter gas, okay, that's emitting inside this tube. All right, and we're seeing that line, and it's sending out all the light you see here. Okay, all the light you see here, actually, in this broad open area here. This is what it's sending out, but it's sending out predominantly in the green right there. Now your eyes are most sensitive to green, so that's why they're not most sensitive to red. That's why red lights are turned on when you are trying to keep your night vision. Okay, because they're not sensitive to that. So that said, this is a cool add-on we're going to use in the observatory, and we'll have that up and running as soon as I get a way to connect the spectrometer to the telescope in the way that I want to. And it'll be connected out west as well, so that we can watch it and do all the spectra from there. Tina Pewterbaugh is here. Hello, Tina. What's up? Hey. And Carol, I don't know if I said hi to you, but I think I meant to. So that's what's coming soon. Now we come back to our view, and you can see that unfortunately we still have clouds. I've been doing my best to kind of forestall the clouds, but this is what we got going on right now. So not a very good night for astronomy. It started out like it was going to be. And yes, I watched Crew Dragon launch, and it's like they were launching from a luxury car, wasn't it? I mean, it's just like really cool. It's like it was a typical Tesla rocket, touch screens like in a Tesla, which are really cool. And Douglas Trumbull was here today. He came down. We're working on that Nikola Tesla movie, and I had made some stuff for the hydroelectric dam scenes that we're doing in the movie, and he was sitting here, and we were looking at the launch screens. He goes, how are they going to be able to touch those screens with all the vibration of the launch? He goes, I'm not sure I would trust those. And I looked at him and I went like this. I went, big buttons, big touch buttons on the screen. Pretty cool. Hey, Kathy Pernisek, how are you? Welcome. We're waiting out the clouds, and unfortunately, it looks like the clouds win. It is going to get clearer later. I'll wake up to a beautiful blue sky, because that's what we're slated to do. I'm going to look one more time at the actual live cloud feed that I have. It's not just the weather; it's actually an actual live feed of the clouds that will help us figure this out. Yeah. Okay. Yeah, these are going to be here for about, well, it won't clear until morning. So, guys, I am sorry. I tried. I thought this would be really good. We'd be able to do it, but this is just not helping me. So what I'm going to do is I am going to close down. I want to thank you guys for coming. I will... however, I will make sure that we do stream on the next clear night. And that's good. That's good, Kathy. And I don't want you to lose heart. I don't. I'm very excited about what we do here. And with Marianne Rob's help, we're going to be putting in that observatory on, well, just a few days, actually. From now, I'll be flying out to Arizona and putting in the building. We have a building crew coming out. They're going to build the observatory. And that is going to be, that's going to be where it becomes real. We have to build the roof separately. They'll build it on the building, but not attached to the building, and then they're going to take it off the building and reinforce it because it's going to be a roll-off roof. So they'll temporarily nail it to the building, and then we're going to pop the nails, and it'll slide out on rails off the building. It'll be motorized, so we can do that. And I wrote a program to actually control the observatory, so we'll be able to actually, in fact, control the observatory. That's kind of important, So it should be good. I don't doubt it. I'm gonna turn on the infrared out in the observatory so we can see a little more what's going on. So the bottom line is that we're gonna be in good shape. We will be in good shape. We'll be in good shape. Now, as far as what we saw earlier, what we were able to see, we did have this view of the moon, and I think Brian actually asked if we could, look at the south pole of the moon. So I went to the south pole for him. Hey, that's what we do, right? We're always trying to be very helpful here. So, and that south pole looked pretty nice, except that it didn't pan out. We didn't get to spend too much time there because the clouds rolled right in. All right, guys. Well, look, thanks for coming out. I really appreciated this visit with you guys. I think that it was marvelous that you could join me here. And this is our world. This is SkyTour LiveStream. This is our world this is our planet. This is the SkyTour LiveStream planet right here. East. This is the east planet. The west planet's going to have a similar view, but a little bit more brown because there's more sand, and you're going to see some saguaro cactus, big tall cactus. Because on the 5-acre area that we have out there to put the observatory on, graciously afforded us use by a scientist who owns the property and a good friend. We will have these beautiful saguaro cactus, and once we get the Wi-Fi tested and running, which we're going to do this month when I get out there, we're going to actually do a little bit more and do some testing as well. I've got the computer for the observatory. I've got it over on my shipping table, which you can't see. It's over there. And I have to assemble it and put it together, tune it, put all the software on it, put an operating system on it, and we'll be ready to rock and roll. Then I send it out, and it will be ready to be installed in the building out there. All right. So you guys, you have a good time tonight. I will also do my best, and I hope you guys have a good night, and I will see you again when we do this again, which won't be too long from now. Good night, all. You and don't forget, you wake up and have a pleasant tomorrow. See you later.